All right, let's dive into Xenon today. We've got, some excerpts from Wikipedia and a summary of Xenon's discovery. And let me tell you, there's way more to this element than you might think.
What's really interesting about Xenon is that it's kind of a reminder that we're still discovering new things about our world, like even the basic elements.
Yeah, for sure. So it's 1898, right? And we've got these two chemists, Ramsey and Travers, who are like on a roll. They've already found krypton and neon.
Exactly, and they're using this new liquid air machine to separate out parts of the air.
Yeah.
And what do they find? This tiny, tiny bit of something that's totally new. They called it xenon, which means stranger in Greek.
Wow, so they found a brand new element just like hanging out in the air we breathe. That's crazy.
Yeah, it is pretty wild, especially when you realize how rare xenon actually is. We're like in 1 part in 11.5 million. That's like nothing. Like argon, which is another noble gas, makes up way more of the air, over 1%.
So if it's that rare, it must be super valuable, huh?
Oh, absolutely. The rarer something is, the more it's worth. That's why you see argon used all over the place in like welding and light bulbs. But xenon is more, specialized.
Okay, before we get into all the cool things xenon can do, I'm curious about the element itself. Like Wikipedia says it's a dense gas. How dense are we talking?
Look at this. Liquid xenon is denser than granite.
Wait, hold on. Heavier than a rock. Seriously.
It's true. And here's another interesting thing. Because it's so dense, liquid xenon is a really good solvent. Like, it can dissolve stuff that normally wouldn't mix, like hydrocarbons and even water.
Huh, that's weird. I usually think of solvents as liquids, not gases. How does that even work?
It has to do with the way the electrons are arranged in a xenon atom. They, create this strong attraction to other molecules.
So like a molecular magnet?
Yeah, kinda. And here's the kicker. Under a lot of pressure, xenon can actually become a metal, and get this, it's sky blue.
Blue metal? What? Isn't metal like silver or gold or something? I've never heard of blue metal.
Most metals are, yeah.
Yeah.
But xenon is different. It's got this weird electron behavior even when it's a metal, which makes it absorb red light and reflect blue light. That's why it looks blue.
Okay, so we've got this dense blue metal-making element hiding in the air. This is already blowing my mind. But what about this whole noble gas thing?
Ah, yes, the noble gases. They're famous for, not reacting with other elements. For a long time, people thought xenon was just like the others, chemically inert, happy to be on its own.
Right, because it has a full outer electron shell, so it's stable and doesn't need to react, right?
Exactly. It seemed like xenon was perfectly content just doing its own thing. But then, in 1962, a chemist named Neil Bartlett came along, and, well, he changed everything.
So this Neil Bartlett guy, he totally busted the myth that noble gases don't react. What did he do?
Well, he figured out a way to make a xenon compound, which proved that xenon could, react with other stuff.
Oh, wow. So xenon isn't so noble after all. What kinds of compounds can it even make?
Most of them involve elements like fluorine and oxygen, those elements that really want to grab electrons. So you got your xenon fluorides, your oxides, even some with carbon in them.
Sounds pretty intense. I bet you can't just whip those up in your kitchen.
No, definitely not. You need some serious equipment and know how to work with xenon compounds. A lot of them are super reactive, even explosive.
Yikes. Good to know. But I guess that reactivity is what makes them so useful, right? All those crazy applications we were talking about.
You got it. Xenon is a real multitasker. Let's start with something you see every day. Lighting. Those super bright headlights that seem to, cut through the darkness and camera flashes?
Yeah.
Those use xenon. And even some bactericidal lamps that kill bacteria, those use xenon too.
So, every time I see those intense white headlights coming at me, that's xenon gas I'm seeing.
Yep, that's xenon in action. When you run electricity through it, it gives off a ton of light. And since xenon can handle high temperatures and pressure, it's perfect for things like, really bright lights.
Makes sense. What about those xenon arc lamps they use in movie projectors? Are those similar?
Same idea, but way bigger. They make a continuous, really strong light that's pretty close to sunlight in terms of color temperature. And it's not just movies. They use them in things like sunlight simulators and those crazy, powerful flashlights that could probably light up a whole block.
So xenon's like this master light manipulator. I never realized it was used in so many things.
You're catching on. But wait, there's more. Xenon's also making waves in medicine, believe it or not.
Yeah, I remember reading about xenon being used as anesthesia. Seems kind of out there, breathing in gas to knock you out for surgery.
It might sound weird, but it's actually really safe and effective.
Yeah.
Way fewer side effects than a lot of the other options out there. Some studies even say it might be safer than being awake.
Seriously, How is that even possible? What makes it so safe?
Well, for one thing, your body gets rid of xenon really quickly. So you wake up faster and you're not as groggy. Plus, it's not toxic and it doesn't irritate your lungs like some other anesthetic gases. There's even some evidence it might protect your brain during surgery.
That's amazing. Why isn't it used more often then?
The main issue is cost. Remember how we talked about xenon being rare? Well, that makes it expensive to produce, so it's a more expensive option for anesthesia.
Oh, right. But what about those other medical uses like neuroprotection and imaging? Those sounded pretty futuristic.
Yeah, those are definitely cutting-edge areas of research. There's been studies showing that xenon might be neuroprotective, meaning it could help protect your brain from damage after, say, a stroke or a head injury.
Wait, so it could actually help prevent brain damage?
It's showing some promise, but they need to do more research before it becomes a regular treatment.
What about the imaging stuff?
They're looking into using xenon as a contrast agent for MRI scans, to make the images clearer. They use this special technique called hyperpolarization, which makes the xenon atoms give off a really strong signal. So you get these super detailed images of organs and tissues.
Hold on, so xenon can help prevent brain damage and make medical imaging better. This element is full of surprises.
It really is. But there's another kind of controversial use we should talk about: sports doping.
Oh, yeah, I think I saw something about that. Is xenon going to be the next big performance-enhancing drug?
It's kind of a gray area, to be honest. There is some evidence that if you breathe in xenon, it might boost your red blood cell production, which could, in theory, help athletes by getting more oxygen to their muscles.
Yeah, I can see why athletes would be tempted to try it, but is it even safe?
Well, the research is still ongoing, and there's some debate about how strong the evidence is. But the World Anti-Doping Agency, they're not taking any chances. They've already banned xenon.
Wow, so that's a pretty big statement. But speaking of pushing the limits, xenon is even being used in space, right?
That's right. It's a key ingredient in ion thrusters, which are these super efficient engines for spacecraft, especially for those long missions.
Like those cool blue glowing engines you see in sci-fi movies, are those actually powered by xenon?
They could be. Xenon's a perfect propellant for that kind of engine because it's inert, it's dense, and it's easy to store. Plus, ion thrusters are so efficient that they can run for years, letting spacecraft travel incredible distances.
This is blowing my mind. I feel like we've covered so much already, but I bet you've got even more xenon trivia up your sleeve. What else you got?
Oh, there's always more. Did you know xenon has a bunch of different isotopes?
Isotopes, those are like different versions of the same element, right?
Exactly. Some are stable, some are radioactive, and they each have their own special properties that make them useful for different things. Like, scientists use xenon isotopes to study nuclear reactions, figure out what meteorites are made of, and even date events from way back in the early solar system.
Whoa, that's way beyond my chemistry knowledge. We could probably do a whole deep dive just on xenon isotopes.
We could. And here's one more fun fact just for kicks. You know how helium makes your voice all squeaky?
Yeah.
Well, xenon does the opposite. It makes your voice deeper.
Wait, so instead of sounding like a chipmunk, I'd sound like Barry White.
Pretty much. It's because xenon's so much denser than air, so it slows down the vibrations of your vocal cords. Makes your voice lower. But don't try inhaling pure xenon, okay? It's dangerous.
Noted. So after all that, I think my brain is officially full of xenon facts. I never thought I'd find noble gases so interesting.
I know, right? They don't always get the attention they deserve, but they're actually really important in a lot of different fields. And xenon, with all its quirks and uses, it's a real standout.
Speaking of quirks, you mentioned something about xenon forming these weird things called clathrates. I remember seeing that in the Discovery History notes, but it wasn't in the Wikipedia excerpt.
Oh yeah, clathrates. Those are pretty cool. They're like these tiny cages made of other molecules. And xenon atoms can actually get trapped inside. It's kind of like a molecular prison.
Molecular prison? That's pretty wild. How do the xenon atoms even get trapped in there?
It's not really like a regular chemical bond. It's more like they're physically stuck. Think of it like, imagine someone fitting perfectly into a really weirdly shaped room. They're not tied up or anything, but they can't get out because of the way the room's built. It's kind of like that with xenon and these clathrates. Weak forces kind of hold the xenon atom in place, so it's hard for it to escape.
So are these clathrate things just a weird chemical quirk? Or do they actually do anything useful?
No, they're actually good for some things. Like, you can use clathrates to separate different noble gases because they form under very specific conditions. So you can, like, set it up so that the clathrate only traps xenon and leaves the other gases alone.
Oh, so it's another way to get xenon out of the air, even though there's not much of it there.
Yeah, exactly. It might not be the main way they do it, but it just shows you how xenon's unusual behavior can be useful in unexpected ways.
It's crazy how we started this deep dive thinking xenon was just this boring, rare gas. And now it's like, wow, this element does so much cool stuff.
Yeah, that's what I love about chemistry. There's always more to learn, and even the things you think you understand can surprise you.
I think it's safe to say we definitely learned a lot about xenon today. Started as a simple deep dive and turned into like a whole journey through all this amazing science.
It really has. We covered everything from how it was discovered by accident to all those crazy applications, from things we use every day to like space travel and stuff.
I mean, we talked about using xenon for everything from deep sea diving to, powering spaceships. This stranger element has definitely made a name for itself.
No doubt about it. And if this deep dive has got you curious, there's so much more to explore. Maybe you want to look into like how xenon isotopes help us understand the early solar system, all those mysteries from billions of years ago.
Yeah, or maybe you'll dive into the whole debate about xenon and sports doping, all the ethical questions that come with that.
There's a whole world of knowledge out there waiting to be discovered, and xenon, it's just one tiny but really fascinating part of it all.
So keep asking those questions and join us next time for another deep dive into something cool. Until then, happy exploring.